The muscle excitation contraction begins with an action potential arriving at a neuromuscular junction. It results in the release of acetylcholine by the motor neuron at the neuromuscular junction. Acetylcholine diffuses through the synaptic cleft of the neuromuscular junction. Acetylcholine binds to the ligand-gated sodium channels at the motor end plate. The motor end plate is a highly excitable region of the muscle fiber, muscle membrane, responsible for initiation of action potentials across the muscle surface. The sodium ions enter the open channels in the sarcolemma of the muscle fiber. This area quickly depolarizes and repolarizes, producing an action potential. This initial action potential begins a chain of reactions of membrane events that causes the propagation of action potentials along the adjacent sarcolemma. The wave of action potentials enters the cell at the T-tubules. The action potentials enter the cell at the T-tubules and causes the calcium channels in the nearby terminal cisternae of the sarcoplasmic reticulum to open. Calcium flows into surrounding sarcoplasm and binds to troponin along thin filaments, and contraction begins. It causes the tropomyosin to change its conformation as it moves physically to the side to uncover the cross-bridge binding site on actin. Myosin cross-bridge attaches to actin and bends, pulling actin filaments toward the center of the sarcomere. ATP binds to the myosin crossbridge, which breaks the actin-myosin bond and allows crossbridge dissociation from actin and sliding of thick and thin filaments. The calcium is actively taken up by the sarcoplasmic reticulum when there is no longer a local action potential. With calcium no longer bound to troponin, tropomyosin slips back into its blocking position over the binding site on actin. Contraction ends, and actin slides back into its original resting position.